Hey everyone, welcome back. In the previous session, we heard from two founders about their startup journey and the lessons that they took out of their entrepreneurship journey. And we're now ready to get started with our next session. And in this session, I'm privileged to be joined by my colleague all the way from Denver. Hi, Darian, how are you doing?
I'm doing well. Thanks so much for asking, Mohan. It's a little brisk this morning, but I'm feeling good. I'm actually ready for the weather to change. It's been hot for a while.
Okay, awesome. Thank you. I know it's fairly early for you, but thank you for making it to this conference and speaking to our community. Darian is go ahead.
I was going to say my pleasure.
All right. Darian is going to be speaking to us about scale, right? How do you as business founders and CTOs and head of engineering think about scaling from day one and not something as an afterthought once you've kind of hit the market and you're scaling rapidly and having lots of users come to your platform. So with that, over to you, Darian, and I'm going to be controlling your slides.
Thanks so much, Mohan. As Mohan said, for you founders and CTOs and maybe heads of engineering, this is going to be a talk where we're discussing how do you think about this stuff in advance, right? How do you plan for this stuff before it happens? Obviously, my name is Darian Wilkin. I've been a solution engineer here at DigitalOcean for about 4.5 years now. Absolutely love working for DO, and I was excited to be able to give this this webinar here today. It's not going to be an incredibly in-depth webinar. We're not going to be going into the command line here. I didn't want to put anybody to sleep, so instead we're going to be keeping it all within the presentation. So go ahead and hit the next slide, Mohan. So here's what we're going to cover. We're going to talk about some important terms first off. Then we're going to talk about what does it actually mean when I say scale ready? What are the concepts we're talking about? Then we're going to cover the basic components of scale, right? What do we think about in terms of what are the pieces we have to scale up? And then finally, for the end of it, we're going to break down a monolith. We're going to take a look at what it looks like when you're built not to scale and how we can take that and transform it into a scalable infrastructure. So next slide, please. What we're not going to cover, building on Kubernetes. Obviously, Kubernetes is great at scale. We're not going to talk about that. We're not going to talk about email security and monitoring at scale. Those are all obviously important, but they're add-ons, right? They're something you tack on to the end. They don't necessarily need to scale with you. We're not going to talk about regional load balancing. Obviously, you can scale with multiple data centers with regional load balancing, not in scope today. We're not going to talk about application-specific scaling. Like I said, I don't want to put anybody to sleep with the command line here. So we're not going to go into specifics of any particular application. We're going to try and keep it broad. Next slide, please. All right, let's get into it. Now that we're done going through the table of contents. Some important terms I wanted to cover here. First of all, vertical scaling. Vertical scaling is increasing the size of individual components of your infrastructure, right? That's as opposed to horizontal scaling, which is where instead of increasing the size, you increase the number of available nodes, right? So those are two kind of diametrically opposed methods of scaling. Then we have the term monolith or monolithic. This is an ancient architecture practice of putting all the components of your application on a single piece of physical hardware. It's a bad idea, right? I mean, just the way I described it was meant to evoke kind of anxiety in you, right? Like, don't do that. It's gonna lead to problems down the road. So that's what we're trying to get away from here. And then state. Maybe a familiar concept to most of you, but it's important when we talk about scale that we talk about state. And state is just any component which has data written to it, right? So we're talking about databases are obviously very stateful. We're talking about storage being stateful, things like that. Oops, I'm pushing my own slide queue buttons. It's Mohan that has control here, so thank you, Mohan. So let's talk about what it actually means to be scale ready. What am I talking about when I say scale ready? And there's three main areas we want to focus on. One, compartmentalized components. Notice I didn't use the buzzword containerized, right? Containerized is not required for scale. It's helpful if you're using Kubernetes. It's maybe easy, more portable, but it's not required to scale up. So you don't have to containerize everything. Don't let people tell you have to be on Kubernetes. You don't necessarily. It's not right for everything. The second piece is scalable components, right? You have to make sure that whatever you're building on, each of your components has room to grow. If you are already using the largest size available for a particular component, then obviously it can't scale up larger than that. So you got a problem in the future. You got to prep for that. And then finally, automatic failover. If it doesn't stay up in the event of a single node failure, then it's not really scalable, right? When we talk about scale, we're also talking about redundancy, failover, high availability, fault tolerance, all those sorts of things. They are part and parcel with scale. Now, we're not going to talk about how to configure each of those pieces of failover here today, but we are going to talk about how they're important. And I want to say, don't get intimidated by this. This is a lot of people avoid scale because when they're starting out, they avoid scaling because they think, hey, this is going to be a bunch of work. I want to focus on this other stuff right now. And you're right, it is some work. You have to think about this stuff a little early on, but I guarantee you, it's much, much harder down the road. When you are down the road trying to scale up after you've already got customers, after you're already going viral and taking off, that's a real challenge because now you're talking about downtime, which is a startup killer, right? You don't want to be the startup that is no longer online, right? People will move to somebody else. So we want to think about scale well in advance. Next slide, please. All right, so let's talk about some of the components of scale. There are really four that I like to think about as kind of the key base things. And like I said, there are other add-ons, right? We talk about email and monitoring. Obviously, those are things that need to scale up eventually too. But like I said, those are add-ons. We'll talk about the core services here. First of all is your load balancer. A load balancer is what sits in front of your application, right? As you can imagine, it balances the load. Imagine that. It's generally stateless. It has to be redundant, and it must be vertically scaled. Now, what do I mean by all that stuff? So obviously stateless, your load balancer isn't storing any data. Now that's important because we don't want to rely on that particular piece of hardware for anything, right? We want to be able to swap that out for another random piece of hardware and not notice a difference. And for that, we need to have it not be stateful. So the load balancer is stateless. It's got to be redundant. If we've got a load balancer that isn't redundant, as soon as it fails, then our entire application is down. That defeats the whole purpose of what we're trying to do with a load balancer, which is reduce single points of failure. If you're using a load balancer that is not fault tolerant, I question what you're doing. It's not very useful without fault tolerance. Finally, that last bullet there in the load balancer section must be vertically scaled, right? Now, this is important because load balancers, by their very nature, unless you're talking about regional load balancing, things like that, load balancers, by their very nature, cannot scale horizontally. They have to have a single point of ingress, right? So we have to be able to increase the size of that individual load balancer node, and we have to understand how to do that live. Then we have the application/web server tier, right? So these are technically usually different tiers. We have somebody running Nginx on one tier and then their actual application on another tier. But they function in much the same way, right? First of all, they should both be stateless, again, for the same reasons as the load balancer. If we want to scale these out and be able to treat them as cattle, not pets, then we need to be able to replace them, which means that we can't store any state on these application or web server nodes. And then again, this one is a bit different from the load balancer because this one is best to scale horizontally. When you have application and web server nodes, we just want more of them, right? We can scale them vertically, sure, but if we scale more of them, then it doesn't matter if more of them fail, right? We can have more failures and tolerate those while still delivering our product to the customer. So best to scale the application layer and web server layer horizontally. Then we have the database. Now this is where we get a little tricky because the database is stateful. It has to be stateful. It's by its very nature, it's stateful. By its very nature, it's stateful. So when we talk about scaling a database, the critical thing that we have to think about is that we can't just destroy the main database and stand up a new one, right? We have to have all of that data saved in order to stand up a new version of that database. So we get into things like read replicas and standby nodes, and we talk about the whole primary replica setup, which we'll talk about in just a minute here. The database especially must be redundant, right? if your database goes down, it's all over but the crying, right? We don't want to see that happen. So the database must be fault tolerant, and that's actually one of the more complex and difficult parts to configure in this entire stack. Is that you have to design that database with redundancy in mind, and nobody wants to be a DB administrator, but we'll talk about that in a minute here. Finally, we have storage, right? Your storage needs to scale. And the only reason I mention storage here is because we have to consider the type of storage that we're using, right? Are we using in-memory caches? Are we using object storage? Are we using block storage? There are multiple different kinds of storage, and we have to understand how our application is going to scale up with those storages. For instance, if there's a maximum block storage size for a particular node, right? Will our application need more data than that? If so, we may want to consider object storage for that particular node. Just considerations like that. We want to look at the maximum available storage size for these sorts of things. Next slide, please. All right, let's get down to brass tacks. I wanted to give you guys a super simple, low-level explanation of what exactly it is we're talking about. And this is kind of what I think of when I think of the monolith, right? This is a single piece of physical hardware. They have everything on the same piece of hardware. Now, I have Nginx in my SQL here. These are placeholders. This is generally accurate for any database or web server that you've got, so you don't need to worry too much about those. And Nginx in this case is also serving as, well, you'll see. It's going to serve as the load balancer. So we got this monolith. What's the first step? Right, so we've built our app, we've built our MVP, which is critical, right? We have to have the MVP first. We certainly don't want to think about scale before we've got our MVP launched, because that's putting the cart before the horse, so to speak. So now we've got our MVP launched, we're happy with it. The next step, the absolute next step, has to be thinking about how do we scale this out, right? If we go viral tomorrow, what's our plan? What's our contingency? And this certainly isn't it, right? We don't want to do this because if any one of these applications fails, it can take down the entire server, right? And obviously it's not fault tolerant or redundant because it's all single applications, right? We're hoping that nothing goes wrong. There are a lot of negatives to this. It also hurts your scaling. Say your MySQL needs 1 more gig of RAM, but the next size gives you 32 gigs of RAM, right? Then you've got to go up a huge size to get that little bit of extra resources, whereas you may be able to do that in a smaller way or in a more right-sized way if you were to go with a distributed model. Next slide, please. So the first thing, the most critical thing that we want to do is break out the database, right? And I talked about this being kind of the hardest thing to do, and that's why we want to kind of do it first. Because once you've done this, a lot of the other stuff is pretty simple, is pretty straightforward. The breaking out the database is tough because typically it requires a little bit of downtime. Even if you're doing a hot standby, things like that, you do have to take time to redirect the connection strings for the rest of your application. You have to stop writes for a little while you're making the changes over. It's just not great. So best to do that while your database is tiny, right? If your database is 40 terabytes and you've got to migrate it, you're in trouble. I mean, I think it's pretty clear that that's going to take a while. You're going to be down for quite some time. Nobody wants that. So we're going to break out MySQL first. And then after we've broken out MySQL from the rest of it, and we got 2 separate nodes here, then we want to go to the next slide, and we're going to break out the web server, right? And then this is where I want to get you, right? I know that this looks super simple. I know what you're thinking. Darian, please tell me you didn't just talk to me for 15 minutes trying to get me to this. No, I promise. We got a little bit more here. But this is what I want to get across, is that it's this simple. Right? Starting out with something as simple as this will get you to where you need to go to scale later, right? It starts that conversation so you don't have to have downtime when you are scaling up later on, which is what we want to do. But let's talk about what it actually does, right? It allows you to do things like independent vertical scaling. Right, so you can see here, maybe I needed a much larger database, but I needed a much smaller web server. I can do that and right-size my components without having to spend way too much money on a huge node that has to manage all of them together. Right? I mean, you've all seen the way that the way that sizing goes, right? It's not 1 gig, 2 gig, 3 gigs, 4 gigs, 5 gigs, 6 gigs. It's 1 gig, 2 gigs, 4 gigs, 8 gigs, 16 gigs, 32 gigs, right? The larger the size gets, the more you have to jump up in cost each time. So if you keep your individual components small, you avoid that. Next slide, please. This setup also gives you modularity. It's much easier to plug and play with additional components like object storage when you've got everything broken out already, right? And it also makes it easier to draw out. We can very easily see that the object storage is what talks, or that my app talks to the object storage here. It's much clearer. It's a much simpler architecture. Next slide, please. Then we've got failover and redundancy. Now this is kind of the big one. This is the one that's tough to do, and especially with MySQL. It's actually pretty simple to do with the load balancer / web server portion, but the MySQL portion, we got to configure this, and we usually have to stand up a second node to do so. This is critical. Obviously, like we talked about, you're not scale ready if you're not redundant for certain parts of for every part of your application, right? We're just not fault tolerant unless we have these extra pieces there. So important to get these out there, and how you do these replicas, these redundant nodes will vary based on the specific applications you're using. MySQL and Postgres have different ways of doing this, for instance. Next slide, please. All right, now we get to horizontal scaling, right? So we had the single app piece in the background. Now, when I talked about getting you to the 1, 2, 3 architecture earlier before, this is the mecca, right? This is where we want to go, because this, I can just start shooting out individual components, right? And it's still going to survive, because if I shoot out the MySQL primary, the replicas are going to take over. If I shoot out the Nginx primary, the Nginx clone is going to take over. If I shoot out 2 of my app servers, the other app server can take over while I'm spinning up new ones, right? We have got an application here that can take being run through by a stampede of bulls. It's just strong, right? We aren't going to have downtime unless we are still scaling up, right? The period in which we actually have to increase the size of these nodes is the only slowdown we'll have. Whereas if somebody had not built their application like this and they reached the point of scale, then of course we're messed up, right? We're going to be worried about how are we possibly going to scale up to meet the demand of these customers without having downtime, which they're absolutely going to notice. And what's important about this is that this doesn't represent a significant cost increase, right? This setup right here, if you're using right-sized nodes, represents maybe a 30-40% cost increase from what the monolithic example looked like. When you look at all the advantages that it gives you, it's very clear that that's worthwhile. Next slide, please. But the real advantage, and of course, what I love about doing it like this, is that I don't actually have to worry about this other stuff, right? I can integrate managed services like DigitalOcean load balancers in front of my application. Then I don't have to configure that Nginx failover, right? That's the critical part here, is that when you break this stuff out, you can replace individual components with managed services. Next slide, please. The real advantage comes with the managed database, right? If you integrate a managed database instead of running your own database, then suddenly you don't have to be a DB admin, right? Nobody wants to do that job. I'm sorry if there are any DB admins in the crowd. I'm sorry for what you have to do on a daily basis. It's rough. But adding in those managed services allows you to focus on other stuff. Go ahead and go to the next slide, please. And object storage is another one of those, right? Everything around your application can be generally managed for you. And why is that important? Next slide, please. Because then you can focus on building what's actually critical for you, right? What you're actually good at. You guys are building an application. You're not building a load balancer farm. You're not building a database farm. You're building your application. You're building something cool, and you know how to build that. You don't want to have to spend hours learning how to configure a fault-tolerant, redundant MySQL cluster, right? That's just a pain. And you don't want to hire a DB admin to do it for you. So why should you? You can focus on your application if you just build if you build your application in a simple way, in a modular, scalable way from the start, then it's super easy to add in these services when you decide, you know what, this is beyond what we want to focus on. It's not a core competency. We want to let somebody else do this. And while you say right now, that's not the case. I'm gonna run my own database. I'm gonna run my own load balancers. Once you get successful, once you reach that point where you're like, oh wow, this is actually a real business now, you won't want to do those things. You'll want somebody else to handle them for you, and you won't want to pay somebody $70,000, $80,000 a year to do it on your behalf. Next slide, please. This is what I wanted to kind of show you guys the real world example of this, right? Obviously, the examples I've been showing you have been kind of simple representations. Hey, here you go. Oh yeah, I was looking at the questions here, but this is a real life example, Gabby, of what we're talking about here. Yeah, where the rubber meets the road, exactly. This is what it looks like in production, right? This is obviously I've abstracted this out, but this is a real customer's production cluster, right? And it looks complicated, especially if you're not super familiar with these types of diagrams. It looks like there's a lot going on here, but it's really simple to break it up into what we were just talking about, right? The 3 components, even the 4 components here. We've got the load balancer tier on the front end. We've got the web server slash app tier. We've got like 5 app tiers actually. Then we've got storage in the form of a cache DB and spaces. I apologize. And then we've got a DBAS cluster. We got a logging service. But these are all just exactly what we were looking at earlier when we were looking at that simple three-piece diagram. This is just a bursted out version of that, right? It is very easy when you build your application with that early scale in mind to reach this point without having to re-architect your entire application, right? That's what we're trying to avoid, is getting to a point where what you really want to focus on is the next feature release, and what you have to focus on is all your tech debt because you built a monolith at the start, right? Next slide, please. And that's pretty much it. That's the long and short of it here. If you guys do want to try out DigitalOcean, Gabby, so please do try do.co/tide100. If you guys have questions about what I talked about here, I'd love to get into it more. You can reach out to me directly at dwilken@digitalocean.com, or you can contact our solutions engineering team through the normal course of business, and I'd love to talk with you guys about how to architect those specific parts of your application. Additionally, like I said, there are application-specific scaling concerns, right? We want to talk about that stuff as well. My team my team in solution engineering. That's what we do all day. We help customers like you. We help people like you who are starting up their business and want to know what are the best practices. How do we do this right? How should we go about this? And that's what we love doing. We love doing it all day. So please contact us. Don't hesitate to reach out.
Absolutely.